Hello, and welcome back to another video. Thanks for tuning in. If you are wondering what you want to do for your next Arduino and 3D printer, this project is perfect for you. This project will teach you some pretty basic Arduino skills while giving you a nice and simple challenge. It is a 3D printed sliding door. The doors are put into motion using a rack and pinion mechanism. By the way, I have a tutorial on my YouTube channel showing just how to create a rack and pinion template using SolidWorks, where you can vary the size of the spur gear and create a rack and pinion. If you're interested in that, please feel free to check out that video. I actually used that template to quickly create the spur gear and rack required for this sliding door project. You'll find the electronic components required in this project in most standard Arduino kits. For example, the spur gear is driven with a 28 BYJ 48 DC motor. The ULN 2003 driver for this DC motor is also common in Arduino kits. The tactile push buttons that fit into the mini breadboard are also common. The only thing that you may not find in an Arduino kit are the end limit switches. However, you may have some laying around from an old Ender 3 that was upgraded. Otherwise, you can order them as they are easy to find. All these components are connected to an Arduino Uno R3 to make this sliding door project. In this video, I will explain how to get and print the parts, do the wiring, run the Arduino code. So stay tuned and enjoy. Here is what the final project will look like. You press a tactile button to put the system in motion. Pressing this button moves the 28 BYJ 48 motor. The spur gear that is attached to this motor then moves the doors. The motion continues until the end limit switch is engaged. The same thing happens when we want to close the doors. You will note the location of the end limit switches.
Okay, these are the I'll start with the electrical components that we need for this project. Here is a 5-volt, 2-amp wall adapter that you'll find maybe as a wall charger for your phone. It should be 5 volts and 2 amps to power your system properly. And then what you'll need to do is for that USB wire that connects to the wall charger, you'll need to cut it and strip it and connect a plus and a minus Dupont jumper wire cable to it so you can use it to power your system by plugging that into your breadboard. So you'll need to cut and strip and solder. Maybe not solder. If you don't want to solder, you can just wrap the wires against each other nicely and then cover it with tape, but I soldered mine. Then the next thing we need, or electrical component, is going to be the 28 BYJ 5-volt motor. This is a DC motor that is connected to the ULN 2003 driver, and there's only one way to connect it, so that's pretty simple. And then you need an Arduino R3, mini breadboard. This one it has about, I think, 29 rows and 10 columns. And some end stop limit switches. These are good for, these are commonly available. And this one has already SVG, signal, ground, and voltage. And this is the common ones for Ender 3s. So you'll be able to find these pretty easily. And then you need 2 tactile push buttons, and these will connect directly into your breadboard. And you'll find these in Arduino kits. They're pretty readily available as well. And then we also need 2 10 kilo ohm resistors for our circuit. And that's it for the electrical components. Now For the mechanical components, we'll need 2 of these 6/8ZZ bearings. These are referred to as skateboard bearings normally. The OD is 20/20/22, the ID is 8 millimeters, and the width is 7 millimeters. We'll need 4 of these. And then we'll also need 4 of these smaller ones, which have an OD of 1 centimeter and an inner diameter of 4 millimeters, and they are 4 millimeters wide, and we'll also need 4 of these. And now for the 3D printed components, this is going to be the elevator car, and it's just basically a car with through holes and some tapped holes. And this is the direction that you're going to want to print it in, so you can get your tapped holes come out cleanly, and you don't need to print any supports. Then we need the holder for the 28BYJ48 holder. This one is simple. And now we have the upper roller holder that you will also need to print out. And always print out your threads facing upwards to get the cleanest threads. These are an M3 thread, so you'll have to, maybe do some fine tuning to your printer to make sure you get those small threads proper. And print it in this direction and also place some tree supports I found worked best. And I use paint on supports and then tree supports here. And I have the threads printed upwards in this direction. Then you'll need a spur gear. Not much to say about printing that, just print it the way it's shown here. And then I have the elevator porch as printed. This one is gonna be long, so you're gonna need to print it on a bigger printer. I printed this part using my 10-log TLD3 Pro, which I think has maybe a build plate of 320 millimeters. I'm not 100% sure, but it won't fit on your typical Ender 3. And then the gate rail also has threaded holes and is long, and this one I also printed on my 10-log TLD3 Pro. And I had to print it out diagonally. And of course, again, as always, I print the threads facing upwards. This one has an M5 threaded hole. And then here is the adapter gate rail to limit switch part. And this one, you can print it facing down maybe. I'm not sure, whatever way you like to print it. There's no threaded holes here. But you will put M3 inserts into these holes. Where I could do M3 inserts, I did, but some places I just couldn't use the M3 inserts, and I'll explain that later. This is the front door right. This part you're gonna print facing down, and I have a quick video on that. And this is the front door left.
There are also 4 rollers that need to be 3D
that.
printed. The skateboard bearings will get press-fitted into these to create the wheels. Here are the bills of materials. The first one is for the metric screws. You will most likely already have some of these screws laying around, especially if you have a 3D printer. Otherwise, they can be purchased from many online stores. I am using the small ball bearings to hold the doors in place, so their length must be close to 12 millimeters as possible because the parts in the assembly are designed around this length. The other screw length dimensions are not as critical. You will also need 4 cubic meters standoffs and 6 cubic meters threaded inserts that are 4.5 millimeters long. Here is the bill of materials for the electrical components. Most of these are also readily available in typical Arduino kits, such as the 28BYJ, 48 5-volt DC motor, and its ULN 2003 driver, a mini breadboard that is approximately 54 by 83 millimeters in length and width, and push buttons. You may have to order the 3-pin limit switches that have signal, voltage, and ground pins. These are readily available online since they are commonly used for 3D printers. The 5-volt 2-amp wall adapter may require some searching, but if you have a bunch of old wall adapters laying around, I am sure that you will find one with similar specifications. You will need to cut the wire of a USB cable and then separate the ground wire from the voltage wire. The wires may be differentiated from one another as one may have stripes and the other may be plain. Next, strip about 1 centimeter of wire and connect it to some Dupont Jumper Wires so we can use it to power the system. The final bill of materials is for mechanical parts. These parts are either printed or purchased. The STL files will be made available with a link in the first comment. There are 8 ball bearings required for this project. A quantity of 4608ZZ and a quantity of 4 MR104ZZ. The 608ZZ ball bearings are used to roll the doors back and forth. These ball bearings are commonly referred to as skateboard bearings, and they have a 22 mm outer diameter, 8 mm inner diameter, and 7 mm width. The MR104ZZ ball bearings are smaller, and they're used to support the door's motion from the top of the doors. These bearings have a 10 mm outer diameter, 4 mm inner diameter, and 4 mm width.
Okay, this is how you're gonna slice the doors. So you're gonna first take a look at the door from the bottom, and you're gonna place a paint on support to the, let's call it a keyway. That, well, it's not really a keyway, it's just a slot. And that slot, the small ball bearing is going to go into that slot, and you'll see that in the animation of the assembly, and it'll become clear. But I picked a small size paint brush, and then I just painted support here, and I'm using 3 supports as well. So just take your paintbrush and paint it all the way down from one end to the other. And I'm showing how to do it here on this part, which is called the front door left. The front door right will be the same. And now we put the paint on supports there. Then we also want to paint our supports on those shoulders here. So just go to this and paint some supports onto here as well. And I'm using 3 supports, as I mentioned. And this is, I printed this in PETG. And I pretty much used, I believe, the default settings from Orca Slicer in PETG. Maybe I just changed temperature, and maybe I also changed the retraction settings after I did a few tests. But other than that, the standard PETG settings from Orca Slicer were great for this, for my setup. And now, once it finishes slicing, you'll see what it looks like. See, I have those 3 supports there and 3 supports on that slot inside. Okay, here is our wiring diagram and how to wire this this project, this sliding door. So this is simple enough. Let's start with the easiest one. You're going to wire your 28 BYJ motor to the ULN 2003 driver. Then you're going to wire the ULN 2003 driver as shown to the Arduino board, in 1 to 11, in 2 to 10, in 3 to 9, and in 4 to 8. Then now we said that there are, let's go to the limit switches next. Each limit switch has an SVG, which is signal, ground, and voltage. Each of the ground is going to go to the ground terminal or the ground row on your breadboard, like so. And then one of your signals is going to go to Arduino D2, and the other signal from your limit switch is going to Arduino D3. So simple enough. I also don't show here the how I powered my setup, which is powered using that 5-volt 2 amp wall charger. You're just going to put one of those Dupont jumper wires to the plus 5-volt rail, and the other one you're going to put it to your ground rail. Okay, the last thing we need to talk about is also we need to make sure it's important to connect your 5-volt from the Arduino to the plus 5-volt rail and the ground from the Arduino to the ground rail. Then we also need to talk about finally the tactile push buttons. The tactile push buttons, one end of it is going to connect to the plus 5-volt, and the other end is going to connect to your signal, your digital signal. You can use D4 or D5, and then you'll have to figure out which one opens and which one closes. And now DeepSeek, or it's like the Chat GPT, told me to connect a pull-up resistor from the other end of the tactile push button to the ground, and do that also for here. I'm not really sure why, but it's just how pull-up resistors work. And that's it for the wiring diagram.
At this point, we have printed the parts and completed the wiring. We are now ready to start assembling. First, add the heated inserts to the guardrail with threaded insert. The front right door part also requires threaded inserts, but there is no animation for that process. The threaded inserts are M3 and 4.5 mm. Next, let's add the wheels to the sliding doors. Each wheel is made up of a 3D printed roller with a ball bearings pressed into it. You might need to slightly heat up the roller to soften it up so that the bearing will fit inside. Don't go get a heat gun now and scorch the thing. An oven lighter works perfectly. After pressing the bearing inside the 3D printed roller, place it in between the ends of the door and screw in the M8 screw. If you have a shorter screw, such as something in the range of 2 centimeters, that would be perfect. But I was working with the screw that I had.
Okay, let's take a look at the animation here of how we're going to put together all of the parts, 3D printed parts, with also the electrical parts as well. So first off, we're going to put the lower roller holder, and we're just going to clamp that onto the elevator compartment using these M5 screws, or I think they might be M4. Now let's just pause the video here slightly. Wait a minute. And just talk about adding these screws. So once you put these screws into your roller holder, you're going to use metal screws into a tapped 3D printed hole. And I tapped this hole instead of using metal inserts because I couldn't get the metal inserts to be perfectly placed, because I was placing those by hand. So if they were a little bit off, it would throw the ball bearings off, and if the ball bearings were off, the door wasn't able to slide nicely back and forth, because this is what's supporting the door and letting it slide back and forth. So you're going to have to be a little bit careful when you're putting these in, because you're going to be screwing metal into a small 3D printed tapped hole. And you can imagine the height of the tapped M3 thread. It might be, less than 0.5 millimeter or so. And you're going to be using a metal screw. So do it carefully and use a small screwdriver. Don't get your biggest screwdriver and tear your threads up. So that's all there is to say about that. Let's keep rolling the film here. And once you also make sure you bottom out and make sure you use the proper size screw, which is 12 millimeters long. So these will be in the perfect position. Okay, and then you can add these components the same way. The holder for the 28 BYJ, a 5-volt DC motor, and the 5-volt DC motor itself. And then add your upper roller holder the same way. Also, when you're tapping these threads, tap them very carefully. Then next, add in your M3 standoffs, which are going to fit into these 4 holes here. This is where the Arduino is going to go. That's why the hole pattern looks a little weird. The Arduino hole pattern is a bit weird. And then you need your M3 screws to screw on from the other side to your M3 standoffs. So there are those standoffs. And then drop your Arduino on there and screw your M3 screws into your standoffs. There's going to be 4 of them. And next, just take your breadboard, that small breadboard. It's got an adhesive side to it. Just slap it onto your elevator car. Put it in the corner. Then add this spur gear to your D-shaped knob of the 28 BYJ motor. You might need to use your lighter. Heat that spur gear up a little bit because it's not going to fit if you try to do it by hand. Heat it up a little bit and then push it in. Or maybe you can do that before you attach the gear to the assembly. Yeah, maybe it's better. Attach the gear to the motor before you attach the motor to the assembly. Not the way I have it shown here. Okay, next we're going to put in what I called the rail porch. It's going to fit onto the elevator car and you're going to screw that in. This has the threaded holes. Those are M5s, so you'll be able to screw them in nicely. And you have 3 holes for your M5 screws. Okay, and then put in your rail. Put in your rail here. Let's rewind it back. Yeah, add the rail, and also you'll use M5 screws, and you have some tapped threaded holes here into your 3D printed part. And this slot will hold the doors that slide back and forth. Okay, next we put in our doors and push your door all the way into the end, and actually make sure you don't have this threaded adapter here when you're pushing in your door, because what you need to do is push your door farther than it will go, so you can add the door on the right. See, notice here we have some interference, so you're gonna not add this part yet, add it afterwards. And now to put in your doors properly, add this first teeth into that first tooth, and the same for this one. First tooth into this first tooth without this part here. Can I hide this? Yeah, let's hide it. Oh no. Let's show it. And let's hide it like this. Yes. So you make sure you don't put that on there yet until you have your left and right doors available. And here I forgot to mention that we need to add heated insert heat your M3 inserts, and I use a soldering gun, and I solder them onto the front door, right, is what I called it. Let's see, let's hide this limit switch so we can see here are your heated inserts. Just heat the inserts using a soldering gun and drop them in there. And then you'll also see some cutaways for the switch to go in there nicely. Okay, and one switch stops the door when it fully closes, and the other switch stops the door when it fully opens. Let's continue with our animation. Started from the beginning, nobody knows why. Okay, well, maybe it's good to review it again, the steps in full speed. Okay, yeah, we know that. We know that. We know how to do that. Yep. Yeah, that's easy. And then slide in your doors. That's also easy. We know how to do that. And slide in your other door. That's also easy. Okay, you don't need to slide it back like that and bring it in from very far. Okay, you don't need to bring it in more than once. Just bring it in once. That's all you need to do. For some reason, the animation is going back and forth. Okay, there we go. Yeah, you don't need to bring it back and forth so many times. Just once is enough. And that's the end of the animation. Okay. Then you turn on your rotor, your gear or your motor, and to close it.
The final part of the video is the Arduino code. I built this using DeepSeek AI chat engine. The Arduino code is found in the description of the video. Thanks, and I hope you enjoyed this video.